Good morning, Bears! You might have seen this on Karate Kid. I don't know what he's doing, but I can tell you this. It can help us learn about thermal energy. Come to Zoom today for the activity to learn all about heat. Heat from the sun. Ooh, that feels good. Heat from a fireplace. Heat from a warm wind coming your way. Or heat from friction. Karate Kid. Bring your hands together. Go as fast as you can. Not so hard that you can't go fast. Not too soft that there's not a little tension. Keep those things going. Go, 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 go. Put it on your face. Oh, it feels good. Where's that heat coming from? Where's that thermal energy coming from? How does heat transfer? How does it get from the sun? Why do I feel so good from something coming from so far away? Thermal energy. Let's do this. All right, there's our video for Instagram I just posted. We've got heat from the sun. We have heat from friction. We have heat from fire. There's heat in a microwave? Huh, how's that happen? Where the heat comes from a stove that doesn't have fire, that just has a surface. Where does that heat come from? Heat or thermal energy are different ways to talk about heat. Heat moves around. Without heat, we would be dead. And so in this unit, Thermal Energy Week 1, we're going to dive into heat, all about heat. I think we'll stay in this unit for 3 weeks, find out the power of heat, the uses of heat, and all about thermal energy. Here we go. There's your little directions, and now we're going to crank through these slides. It's a Monday, get a short day. Just get an overview, beginning of a unit. We'll begin a new unit called Thermal Energy. In this unit, we are going to investigate and answer the question, why do things change temperature? To help us understand this question, we'll take on the role of student thermal scientist and work to solve a problem with the heating systems in a school. First, we'll watch a video message that will help clarify your role and the heating system problem. All videos are in the home unit. As you watch the video, keep these guiding questions in mind. After you will discuss them with a partner. How are the heating systems similar, or how are they different? What questions do you have about how the heating systems work? Which heating system do you think will warm the school more during the winter, and why? All right, once again, problem solvers.
Tired of being cold? Sign our petition to make Riverdale fix the broken heating system.
Hey, want to sign our petition? Sure. Thanks.
Hey Jesse, lunch is almost over. You ready to go?
Yeah, let's go. We got a lot more signatures today.
I can't believe this. It's actually 11 degrees Celsius in here.
Translation, please.
51.8 degrees Fahrenheit.
That's cold.
Yeah, it's the coldest indoor temperature reading this week. What? I've been collecting data.
Well, you can go tell the principal all about it because we finally have 100 signatures.
All right, let's go.
Hello, Riverdale students. Just a friendly reminder, this week's pep rally will be Wednesday at 7:30 p.m. on the football field. There's only 1 week left for this year's fall food drive, so let's make this one count. Kayla, Jesse, how can I help you?
Mr. Chang, I've been measuring the temperature inside every day, and it hasn't gone above 13 degrees Celsius. And today, it was only at 11 degrees Celsius. I think there's a serious problem with the heating system.
The problem is that it's broken. We have a petition signed by 100 kids at school saying that we need to get the heater fixed. We hope you'll take this matter seriously.
I can do better than that. How would the two of you like to help me pick out a new heating system?
For real?
We all know the heater's broken. You want to see the options?
Sure.
What we have here are 2 systems to heat the school, using water that is at a higher temperature than the air in the school.
That's interesting. I always thought heaters just use hot air and blew it around.
The first proposal uses a water heater that heats a small tank of water to 39 degrees Celsius every day. Then that warm water is pumped into a bunch of pipes that heat the school. In the evening, when the water cools down, it's pumped back into the tank and gets reheated for the next day.
That is so smart. This one's my favorite.
Well, wait to hear both of them. The second proposal uses a large reservoir of warm 30 degrees Celsius groundwater. Every morning, water from the reservoir gets pumped into the pipes that heat the school. Then, in the evening, the cool water is pumped out to make room for the warm water in the morning.
This one's really cool too.
I don't know. How could water from the ground be warm enough to heat our whole school?
Well, if the water is warmer than the air temperature.
I guess, but I don't even see how the heat from the water could get into the air for either system. Water and air are separate things. How would the heat go between them?
That's a good question. Maybe. Actually, I don't know either.
Thank you for your help. I'll email you the plan so that you can take a closer look. I love hearing input from students, but lunch is over. Time for class.
But we'd love to help more. Maybe me and Kayla could go research heaters in the library.
Nice try. Off to class.
Jesse, I have a chem lab next period. You know I can never miss a lab.
I know. I was just joking.
All right, got a little problem to solve. We're going to put in a heating system. Before this Amplify, we used to create a whole solar take Burbank off the grid lesson, but we're going to follow along with Amplify on this. Even though the school and the characters you saw in the video are fictional, the problems that you will be investigating in the proposed heating systems are based on real-life situations. Chapter 1 question, what is happening when the air in the school gets warmer? What is happening when air in the school or anywhere gets warmer? How does that happen? In this lesson and many others in the thermal energy, you will need to talk with a partner. We've done that before. That's called breakout rooms. Do the best you can when we're in those to stay on topic and at least answer a couple questions before you digress. We'll begin our investigation by thinking about and discussing the school heating systems you learned about in the video. Look closely at the two diagrams below. Water heater system, groundwater system. Groundwater is down here, pumps in 30°C. Air temperature 11°C. Water heater pumps in 39°C versus 30°C on this one. We have to heat this one before we pump it around the school. Notice the system is the same. This one uses groundwater, which has a steady temperature because the Earth's temperature stays the same. That's why you can go in a cave to escape a snowstorm. You can also go in a cave to escape the heat in a desert. But over here you have to heat the water. Over here we're using the groundwater. This is going to be interesting. How are the heating systems similar and how are they different? Hey, what do you know? We could do one of our double bubble graphs like last week. Similar and differences. If somebody were going to ask you this in a test, you could use a double bubble and write an essay. What questions do you have about how the heating system works? Which heating system do you think will warm the school more during the winter and why? We will begin by investigating this question. How is something different when it is warmer or cooler? Good question. So we have temperature, but how is it different? Before we recommend a heating system, we need to learn how warming and cooling can change the properties of things. When you've just taken a stick of butter out of the fridge, what is it like? What are some of its properties? What about after you've let the butter sit at room temperature for 20 minutes and it gets warmer? What are some other examples and ideas about how things are different when they are warmer or cooler? The investigation question asks how something is different when it's warmer or cooler because you'll be testing out and thinking about how different things change temperature. In this unit, you'll also start to think about what is happening to something's molecules when it gets warmer or colder. Today we will watch a video to investigate how warm water is different from cold water. You'll observe what happens when you add food coloring to a cup of hot water and a cup of cold water. Interesting. Optional, if you have 1 cup of hot water, 1 cup of cold water, and food coloring, you can follow along with this investigation at home. Be sure to follow the safety guidelines on the next slide. So yes, if you guys ever want to do these experiments at home or find ones like it on YouTube, do it. Safety guidelines, review this carefully. You can see in the pictures. Always protect your eyes. Always be careful that you don't get anything on your skin that's going to burn or damage you. If you're working with fire, have a fire extinguisher handy. If you do this activity at home, be sure to allow the water to settle before adding the food coloring. Try not to move the cups once you begin. As you watch the video, focus on the observations. How does the food coloring move? Cold and hot water. Let's do this. What's happening? Remember, cold water, hot water. Cool music. Cold water, hot water. Hip, hop, hippity hop. Bring that water up to hot. You got cold water and you got some hot. Put a little drop, put a little drop. Little drop and the cold water stays. Hot water does something different all day. What's the difference? What's the same? Similar is difference. Use a double bubble map today. Oh yeah. Bring it on. How long is this song? Cold water, hot water. How are they the same? The hot water looks different. The cold water is a little lame. Let's do this. I was a little bored with that song. I had to add a little rap to it. So let's take a look. That was a hot water, cold water. What did you observe about how the food coloring moves in the water? Let's go into breakout rooms. And what I want you guys to do is I want you to talk in your breakout room about what you know about heat transfer, what's happening in the hot water, what's happening in the cold water, what did you see about the differences, why, if you know about it, maybe you did this experiment before, share anything you know about heat over the next 2 minutes. All right, let's go to breakout rooms. Okay, you probably noticed that the food coloring spreads out faster in warmer water. Although the water does not look like it is moving, the spread of the food coloring indicates that there is some movement happening in the water. How did the experiment with the cold and warm water change your thinking about the investigative question on how heat moves? How do things change from warm to cold? How is something different when it is warmer or colder? So what's the difference between warm air, cold air, warm water, cold water? In this lesson and many others in the unit, you will use the thermal energy simulation. We're back to the sims. Remember, anytime we do a sim, you can also just watch the video if it does not work, but I hope it works. The thermal energy sim is a digital model that helps you learn about change. Let's watch our video on the sim. Here we go.
This is the thermal energy sim. You'll use it to learn about temperatures and energy in different substances. To begin run mode, use the Add Sample button to add a small, medium, or large sample of a substance. You'll see a model of your sample here in the box. You can add energy to the sample using the plus sign, or remove energy using the minus sign. Notice that when you add energy, a hot coal appears below the substance. When you remove energy, an ice cube appears below the substance. In the top right, you can turn the View Kinetic Energy toggle on to see the kinetic energy in the sample. The higher the kinetic energy gets, the brighter yellow the sample will become. Use the controls at the top right to pause the sim, change the speed, or reset and start a new run. Let's add another sample using the Add Sample button. You can add or remove energy from each sample, or drag the samples together. When you put two samples together, you can turn on the View Energy Transfer toggle to see the transfer of energy between them. Press Analyze to track how your samples changed. You'll see graphs showing changes in thermal energy over time and temperature over time, with a different line for each sample. You can view one sample at a time, or both. Use the Replay button in the bottom left to show the graphs running over time. If you make a mistake or want to start over, go back to Run and press the Reset button in the top right.
Alrighty, another sim ready to play with. I don't think we're using it today, but maybe. The sim is a model of a real world that helps you understand thermal. What do you think the small circles in the sim represent? All right, we're going to do a Release the Kraken right now. What do you think? There's some clues around if you want to check it. the small circles in the sim represent? What are all these little dots? What do you think? Don't release the Kraken yet. Put it into the chat. It's one word. If you have your slideshow open, if you've done any research, if you kind of paid attention, you might know it. If you don't, that's okay. You can put question mark if you don't know. You can put the word if you do know. Or you can just take a guess. Remember, you don't get a wrong answer here, but if you don't put anything in chat, not good for your grade. 3, 2, 1. Release the Kraken! All right, good job. Yes, molecules. These are little molecules. And once again, we're into the microscopic world where we can't see these things, just like when we studied the human body. But we're now talking about molecules. Bing, 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 bing. Jackpot. So with our breakout rooms, our Jedi Karate Kid activity with heat, and getting through this introduction, this is enough for today. Plus, it's a Monday, short day. So move this molecule slide to the top. I want everybody to see this at the top slide that tells me you're listening. Add 2 to 3 images to this slide and 1 to 3 sentences of a question about molecules, a question about heat, something you know about molecules, an experience you've had with heat, your favorite kind of heat, anything in your own words. 1 sentence is enough. But if you're advanced, you might want to write 2 or 3. You could even write a CER. That's up to you. So there's your basics for the day. Move molecule to the top. And we will kick in tomorrow with there's glossary, but we do glossary. Remember, all these are concepts. We move them to the top as we find them. We found one. Let's move it to the top. And there's a beautiful little image. In this unit, we will describe the smaller pieces that make up stuff by using the word molecule, water molecule, H2O. So go move this to the top. Cool molecule concept slide. Let's do this. Have a great day. Heat!